you guys have a nice weekend? All right, guys, we are going to go on to the next section today. And today we're going to talk about something that you guys have probably not done before. Have you guys ever done anything with an I with a number? Have you ever seen that before? So in our number system, we have real numbers and we have imaginary numbers. And imaginary numbers are something that we had to come up with in math to solve equations that didn't have a real number solution. And last week we were graphing things, and we talked on Wednesday last week that when you had something and it asked you what to solve the equation, what the answers were where it crossed the x-axis. But there are times, like that would be real answers, real number answers. But there were times that we had a situation where our graph did not touch the x-axis and it looked more like this. This is where you would have an imaginary solution, okay? So one of the things that we're going to have to know today is anytime you see I squared, that is equal to -1. And what they use I to designate that it's an imaginary number. But if you ever see I squared, it's equal to -1. I is going to be equal to the square root of -1. So there's going to be times today that we have to take the square root of -5. Anytime you have a negative under a square root, that means you're going to have an imaginary number because we cannot take the square root of a negative number. And how we get rid of that negative underneath is we pull an I out front. And that we can do. It is an imaginary number then, but that would be the proper way to write that. So here are some examples of imaginary numbers. Typically, when you have a square root, you would put the I in front of it. Some kids write it like this. But then it's kind of hard sometimes to tell if the I is under the square root or not. So that's why we have you put the I in front. So there's a couple different types of problems we're going to do today. And the first one is where we're going to have square roots and we have to simplify them with a negative underneath. Okay. So as I was saying, anytime you see a negative under a square root, that tells you right away you have to pull an I out. And then the square root of 49 ends up being a whole number. The square root of 49 is 7. So this would just be 7 odd. Normally, they won't give you something that is a perfect square, and you'll see that in the next one. So now when I go down to B, 27 is not a perfect square, but you know right away that you would pull an I out. And then you want to think, is there a perfect square that goes into 27? that divides evenly into 27. So the biggest perfect square less than 27 is 25, and 25 does not go into 27. 16 does not divide evenly into 27, but 9 does. So how we would write 27 under here is 9 times 3, because that is 27. And then because 9 is a perfect square, you would think, what is the square root of 9? And the square root of 9 is what? Square root of 9 is 3. So we would take that out front. Okay. And then what we would write here is we'd have the 3, we'd have the I because of the negative, and then we'd have a 3 left underneath there still. And when we go down to C, again, right away, we know that we have to take an I out. And then we think of what is the biggest perfect square that goes into 32? So less than 32 would be 25. And if you took 32 divided by 25, you'd get a decimal. How about 32 divided by 16? Does 16 go into 32? It does. So I could write this as 16 times 2, because 16 times 2 is 32. And then the square root of 16, I can take out front, which is 4. So that would be 4i times the square root of 2. Then when we look at 72, okay, first of all, we know we have to take an I out. With 72, we're thinking, what is the biggest perfect square that you can take out front? Okay, the biggest perfect square that you can take out front. So you always want to look at this chart and look at what's the biggest one on here that's less than 72, and it's 64, and that does not go into 72. 49 does not go into 72, but 36 does. You always want to use the biggest one. You also may have thought that 9 goes into 72, and it does, but you want the biggest perfect square that goes in, and it's 36. So if I wrote this as 36 times 2 is 72, and then 36 is a perfect square. The square root of 36 is 6. So when I write my answer, I'd have 6i times root 2. Okay. Now, when I go to do E, first of all, I have a negative root 3. So that would be I times root 3. Okay. Then I have the square root of negative 15. So that would be I times root 15. Okay. Now when I do this, I can try to combine these, and what I'm going to do is I'm going to multiply my i's. I times I is I squared. And then when you have like root 3 times root 15, you can write it as root and then just multiply these two numbers, which is 45. Okay, now 45, I would have to think of what's the biggest perfect square that goes into 45. 36 does not, 25 does not, 16 does not, but 9 does. So this would be I squared, and 9 times 5 gives me 45. And then the square root of 9 is 3. Okay. Now, whenever you have an I squared today, we talked about this a little bit up here, I squared is equal to a negative 1. Okay, so this would be 3 times a negative 1 times the square root of 5. 3 times -1 is -3 times root 5, and that would be my answer. Now, this one we're multiplying, okay? So you're going to multiply your numbers like normal and then just multiply your i's. So 4 times 7 is 28. I times I is I squared. And remember, anytime you have an I squared, it's -1. So this is really 28 times the -1, which is -28. Then if I look at this next one, I have a -5 times 3, which is -15. I have I times I, which is I squared. Now, I squared is a -1. -15 times a -1 is 15. Now here, notice we have a negative times a negative, and a negative times a negative is positive. And then we have 2 times 5, which is 10. 10 times 6 is 60. Okay. And then we have I times I, which is I squared. So the I squared again is a -1. So that is -60. Now, when I look at D, I'm going to keep that 4 there. Now, when you take a -3 squared, you guys know what happens when you square a negative? It becomes positive, right? So it'd be a +9 and then I squared. And remember, I squared is always -1. So this is really 36 times a -1, which is -36. Okay. Now, when you look at our numbers system, I'll just kind of show it here in this Venn diagram. So real numbers would be everything you've learned up until this point. 0, all our whole numbers, all our negative whole numbers, which are integers. It would be your decimals, it would be your square roots, it would be your fractions. That's everything is the real number system, okay? Then today we're adding in the imaginary numbers, which means they'd all have an I in it. Okay, so that is our imaginary system. And when you put these two together, you make something called a complex number. And a complex number has a real part to it as well as an imaginary part. So it's complex, it has a real and an imaginary part. Okay, so that's basically what all of this talks about. So let's go to this page. So what we're going to do next is we're going to like add and subtract and multiply and divide complex numbers. Now, when you're adding, you're just going to add the real parts. And if it would help you, when you do this, when it's addition, you don't have to worry about the parentheses at all. You can just kind of ignore them. But you're going to add the real parts, and 5 plus 2 is 7. And then you're going to combine your imaginary parts, and -7i plus 4i is -3i. And this would be your answer. Now, when you subtract them, that's a little bit different because you're subtracting both of these. Now, when I explain this, what I would do first is rewrite it without parentheses. The first thing stays the same, okay? But when you have a minus sign in front of parentheses, you have to change the sign on everything inside of it. So right now, that's a +3, so it would become a -3. Right now, this is a negative 6i, so it would become a positive 6i. Another thing kids will do if that's confusing is they'll think of this as -1 times each of these. And -1 times 3 is -3, -1 times -6i is plus 6i. Now we can combine our real parts, and 4 minus 3 is 1. -8i plus 6i is minus 2i, and that's our answer. Now, if we look at this one, this is addition again, and you could just combine the real and the imaginary. I'm just going to write it without parentheses, but you wouldn't really have to do that. When it's addition, you're just going to combine your real. -2 plus 1 is -1. 5i minus 7i is minus 2i. And then this last one, we would just write that first one just as it is, but we would change the signs of both of these because of the subtraction. So it'd be a +1 minus 2i. And then combine your real parts, which would be 5, 6i minus 2i is 4i. So that's adding and subtracting. Okay, now what we're going to do is we're going to be multiplying two complex numbers, and we're going to be using FOIL, where you first multiply the first in both of your parentheses. O is for outside, which is this purple. I is this bluish green, which is your inside two. And L is the last, which is this green. Okay, so we're going to do that. And then one of the things we're going to do today when we're dividing by a complex number, we're going to talk about how you have to multiply by what's called its complex conjugate. So if this is my complex number, the complex conjugate is the same exact thing, except you change the middle sign. Okay, so here is your regular complex number. Notice the only thing that changes is the middle sign. Okay, the only thing that changes is that middle sign. The beginning sign does not change, just that middle sign. And we'll talk about that when we're doing the division. So we are going to FOIL this. Okay, so what we're going to do is we're going to do our first, which is 3 times 3, which is 9. Okay, O is outside, which would be 3 times a -4i, which would be -12i. Then we're going to do inside, which is these two, which is going to be plus 12i. And then L for last would be these two. 4i times a -4i is going to be -16. I times I is I squared. Okay. Now, I will tell you guys, if these two are ever exactly the same, except for the sign in the middle, what should happen is your middle two terms should cross out. Okay, but they'd have to be exactly the same, except for the signs. So if you notice -12i plus 12i, those do cancel. Okay, then you'd have 9 minus 16, and what would I put in for that I squared? A -1, okay? What's a -16 times a -1? Isn't that a positive 16, right? And 9 plus 16 is 25, right? Now, if you look at this one, these two are not the same. and they're not off just by a sign. So that means your middle terms are not gonna cross out. So first would be multiplying those two. 7 times 2 is 14. 7 times negative 3i is negative 21i. Negative 6i times 2 are the inside ones, and negative 6i times 2 is negative 12i. And negative 6i times negative 3i, a negative times a negative is positive. 6 times 3 is 18. And notice I times I is I squared. Okay. Now I can combine these two. Negative 21 minus 12. If you're not good at doing that, just use a calculator and type in negative 21, subtract 12. You'd get a negative 33, and then we have that I. Do you guys get here? Wouldn't this be 18 times a negative 1, right? So that would be negative 18. Because I squared is negative 1. The only thing we have left now is to combine those two. 14 minus 18 is negative 4. And then we have minus 33i. And another thing I should say too, when you have a real part and an imaginary part, you should put the real part first. Now, C is where we have to multiply whenever you're dividing by a complex number. What you have to do here to get rid of that, you can't have an I on the bottom. So what we do is multiply the top and the bottom by the complex conjugate of this. We talked about this a little bit up above, but what it is it's the same exact thing, but we switch the middle sign. Okay, so I multiply the top and the bottom by that. All right, 5 times 3 is 15. I'm just kind of distributing this 5, and 5 times a negative I is minus 5. Then I would distribute here, okay, or not distribute, FOIL, sorry. So we'd go 3 times 3 is 9. Then I would go 3 times a negative I, which is negative 3i. Then I go I times 3, which is a plus 3i. And then I do I times negative I, which is negative I squared. Now notice these two are the same exact thing except for the sign. So our middle two terms should cancel out. Okay. So I get 15 minus 5i on top. And then I have 9 subtract. What do I put in for I squared? A negative 1. Okay. Now I'm going to leave this as 15 minus 5i on top. And 9 minus a negative 1, I'm going to change this to plus because I had 2 negatives in a row and it's over 10. Now I'm going to look to see if I left it as that. I think I probably simplified it. So just give me 1 second. Should check what I did here. So if we go to chapter 3, completed notes, this one. Okay, I did simplify it. So if we were on a test, I would probably be fine if you guys left it like this. But if you see that the same number goes into all three of these, okay, what you can do is divide each of these by 5, okay, and simplify it. So, yes, okay. But like I said, if you left it at this, I probably would not do anything, but 5 goes into all of these. So it's like you can divide each term by 5. 15 divided by 5 is 3. 5i divided by 5 is I. 10 divided by 5 is 2. Okay, but that's a very small part of that problem. So we're going to do one more like this, where I multiply the bottom by what's called the complex conjugate, which is the same exact thing, except you put a minus sign in between. And then I also would have to multiply the top by that. So on top, you distribute 2i times 3 is 3i, minus 2 times 6 is 12. Now, I times I is I squared. And if you wanted to get in the habit of any times it's I squared, just put in a -1, you can do that. Now we have 3 times 3, which is 9. 3 times a -6i is -18i. 6i times 3 is plus 18i. And 6i times a -6i is -36i squared. Okay. Now, on top, I'd have 6i. -12 times -1 is plus 12. Again, on the bottom, the middle 2 should cross out because they're exactly the same. And then, do you guys get how this is really -36 times a -1? And 36 times a -1 is plus 36. So then I'd be left with 6i plus 12 over 45. And again, if you left it like this, it's not the end of the world. But if you look at these 3 numbers right here and checked, is there a number that divides evenly into all of them? 3 does. So you could say 6i divided by 3 is 2i, 12 divided by 3 is 4, and 45 divided by 3 is 15. But a number would have to go into all 3 of them to be able to do that. I just want to see. Yeah, I did that on that too. So now if we go to our last page, this one, we are going to be solving an equation and then simplifying it. And when we solve these equations, the whole reason they came up with the imaginary system is we're going to be dealing with an imaginary number. So if I look here and I asked you guys to solve this, we would first subtract 64. And we would get x squared equals a -64. And do you guys remember what to do if you have x squared and you want to get rid of the squared? You take square root, yes. So if I take the square root of both sides here, okay, what you would do whenever you take the square root, you're going to put plus or minus, and then the square root of 64 is 8. And what do I do with that negative? What do I take out? For that negative, you take out an I. And that is our answer. So whenever you take a square root like that, you put the plus or minus in front of it. Now this one, if I bring that 100 over, I'm going to subtract it. And I get 4x squared equals -100. Then I divide by 4. And x squared equals -25. So to get rid of that x squared, we take the square root. And so x is going to equal, whenever you take the square root, you go plus or minus. Square root of 25 is 5. And because of that negative, I have to take out an I. Now here, I'm going to subtract 35. And I get 5n squared equals negative 35. Divide by 5. And n squared equals negative 7. Then to get rid of that n squared, you're going to take the square root, and it would be n equals plus or minus. Now, because of that negative, I have to take out an I, but I can't reduce the square root of 7 at all because a perfect square does not go into it. So I would just leave that as square root of 7. And then this last one, we're going to subtract 18. And I get x squared equals negative 18. Then I take the square root. And it's going to be plus or minus. I take out an I. And now this we talked about right at the beginning today. Is there a perfect square that goes into 18? Doesn't 9 go in there? So I would think of this 18 as 9 times 2. And I can take the square root of 9 is 3. So what we would get is plus or minus 3i times the square root of 2. So that's kind of putting together a lot of the stuff that we did. That one's harder. All right, so I have a worksheet for you guys today. And then I can find the key to.
According to the National Highway Traffic Safety Association, and who uses bicycle the most? Young people do. Student drives. This year, make it your objective to forget about your phone while you're driving.
So I'm thinking about key
Up to 24 times. Texting takes just 1 second.
and I believe I put it on the weekly snapshot too.